Okay, so hello, and in this video, we would now be designing a doubly reinforced concrete beam. So from the previous video that I have posted, we have indicated there that the first step is for us to get the total ultimate moment. So this is to be the required strength. And after which, we would now be solving for the nominal moment using the value for your phi and your mu. And then, what else? We would now be solving for AS max. And there. Basta yun. Diretsuhin na lang natin. Okay, so let's go from step to step. So the first step, once again, is for us to get the value for your mu. And in this problem, as you can see, we have here your moment as brought about by the dead load and the moment as brought about by the live load. So there are two possibilities. So the first possibility is to be your 1.4 dead load or 1.2 dead load plus 1.6 live load. So whichever is higher there would be the more critical one. So that is to be the governing one. So looking at the calculator to your left. So for the first one, so 1.4 times, so what is to be the dead load? That is to be 308.72 as given in the problem. So our answer here is to be 432.208. Okay, so that is for your MU number 1. I mean for your, yes, MU number 1. And as for the second possibility, so that is to be 1.2 times dead load, and our dead load is 308.72 plus 1.6 times what is to be the live load, that is to be 174.71, I should say. So with that, this is now to be equal to 650. So exactly 650 kilonewtons, kilonewton meter. And with that, guys, we can safely say that this is to be the governing value. So with that, guys, our mu is now to be equal to 650 kilonewton meter. So there. So that is to be for our value for your mu. So the second step is for us to determine the value for our mn. So for our mn, guys, so if you can remember, phi mn should be greater than or equal to mu. But let us just equate this first for the simplicity of our solution. So phi mn is to be equal to mu. So meaning ito na yung pinaka worst case scenario. Dapat mas mababa. Actually katapat niya na pero better if mas mataas. Okay. So solving for the value for your mn, so just divide both sides by the value of your phi. So with that, guys, so mn is now to be equal to mu divided by phi. So with this, guys, so mu divided by phi, that is to be 650 kilonewton meter divided by phi. So what is to be the value of phi? So here, guys, we have plenty of probability for your phi. So that may be 0.9 or the value here. It will depend once again upon which raw max you will be using. So if you will be using the raw max for tension control section, which is to be this, so pag ito yung gagamitin nyo for tension control, the value for your phi is equal to 0.9. Since of course it is to be ensured as tension controlled because the strain that you have used there is to be 0.005. So nandito siya sa area na to, exactly at this location. So once again, if you would be using this raw max, the raw max as brought about by this strain, you would be using 0.9. But if you would be using the NSCP provision of raw max, so for raw max, where is that raw max? Raw max. So raw max, if you would be using this instead, you would still be solving for the value of your phi because your strain T is to be 0.004. Okay, so if you can see, guys, this is to be 0.005 and this is, let's say, so what is to be the value of your Fy? So I think it is better if I would just be drawing this like this. So once again, this is to be 0.9 and this is to be 0.65. So we have a line here, a line here. So nasa transition zone kasi siya, guys. So let's say that this is to be the value for your what do you call this? So this is to be the value for your strain T, which is 0.004, and this is to be for the value for strain T equal to 0.005, and this is to be the value for, this is to be a strain Y. So your strain Y is to be Fy divided by 200,000. So our Fy in the problem is 420. So with that, guys, looking at the calculator once again, 420 divided by 200,000. So that is now equal to 0.0021. 021. And in some cases, guys, they omit this last digit, which is 0.002. But I think it's better if you would be using 0.0021. Anyway, so getting the value here is as easy as ratio and proportion. So let us get this big triangle here. So this is to be your big triangle. Then compare it with the ratio of the smaller triangle. So this is now to be the smaller triangle. So for the bigger triangle, guys, that is to be, so what is to be this length here? That is to now to be 0.9 minus 0.65. Sorry. So 0.9 minus 0.65, that is to be that length. So 0.9 minus 0. Sorry. So that is to be the numerator divided by what is to be the run. So that is to be 0.005 minus 0.0021. So 0.005 minus 0.0021. So that is for the denominator. So you would now be equating this to the ratio of the smaller triangle. So for the smaller triangle, so that is to be, if this is to be your phi. So if this is to be your phi, so with that, guys, once again, this is to be your phi, which is to be this value. So that is to be equal to phi minus 0.65. So minus 0.65 because we are only getting this. Then, what do you call this? So phi minus 0.65 divided by this run, and that is to be 0.004. So 0.004 minus 0.0021. So shift solve na lang natin. So via shift solve, so 0.9 minus 0.65 divided by 0.005 minus 0.0021. This is equal to P or alpha x minus 0.65 divided by 0.004 minus 0.0021. So shift solve. Our answer here is to be 0.08137 something. So 0.813793. So this is to be for your phi if, for example, that you are using this strain for your raw max. So ayun. So if I would just be indicating here. So if strain T is equal to 0.004 for raw max, your MN is to be equal to 650 divided by, so 0.813. So 0.813793. So I think it is better if you would just be using the fraction counterpart of that value. And that is 118.1145. So that you do not need to round off any longer. Anyway, so that is to be the value for your MN if you would be using strain of 0.004. So 650 divided by answer. So our MN here should be 798.7288. Once again, if your strain T is to be 0.004. And if it is not given in the problem, guys, since it did not indicate in the problem that you will be using NSCP provision, so it is better for you to use strain T equal to 0.005 for raw max. So with that, guys, if this is to be the value for your for your strain T, it means that your MN is basically equal to 650 divided by phi. So our phi here is automatically 0.9. So automatic yan. If you would be using 0.005 for your strain, that your value for phi is automatically equal to 0.9. So with this, guys, so 650 divided by 0.9, that is to be 722.22 kilonewton meter. Okay, so take note of this, guys. So we have two answers here for your MN, and it will depend upon the given. So if it is to be, if it is said there that you will be including NSCP provision, you will be using this as your MN. But since it is not, the value that we will be using here is to be this. So ito yung gamitin natin ngayon since it is not indicated in the problem that we will be using this. Okay, so moving forward, so I will just be copying this. So moving forward, since this is already our MN, so we will now check if we really need to design it as a DRB or as an SRB. So spoiler alert, of course dapat DRB to kasi kung hindi, mali yung title na nailagay ko sa video. So for the value for your MN, that is to be 722.22. So MN is to be equal to 722.22. Now the next step is for us to solve for the value for your MN1. And we would be comparing it here. So once again, if MN1 is to be less than 722.22, then it means that we will indeed design this as a doubly reinforced concrete beam. So let us now solve for MN1. So for the value for your MN1, so there are many approaches for you to get your MN1. So you can solve for either of the following as long as you already know how to use this diagram. So let's say for your MN1, what do you call this? Ano bang gagawin natin dito? So let us solve for rho, for your rho maximum. So rho maximum. So for your rho maximum, this is to be equal to 0.85 times betas of 1 times Fc prime divided by Fy times, okay, so once again, we will be using 0.005 for rho max. So with that, guys, this is to be 3/8. So once again, if you would be using NSCP provision, this should be 3/7, not 3/8. Okay, and from that, guys, so for your rho max, this is now to be equal to, so 0.85 times betas of 1. So what is to be betas of 1? So if your value for your Fc prime is to be 28 megapascal and lower, your betas of 1 is automatically 0.85. So times 0.85, so times 0.85 times Fc prime divided by Fy, that is to be 28 divided by 420. So let's just go back to our diagram, to our solution. So 28 divided by 420 times 3/8. So our maximum rho or our maximum steel ratio is to be 0.0180625. So this is to be our value for our rho max. And for our AS max, so AS max is equal to rho max times BWD. Okay, so with that, our BWD are as follows. So we have here your, so hindi ko na ilagay dito yung BW, so for a while. Okay, so I forgot to include a beam width here. So let us add BW to be equal to 300 mm. So let us use this as our trial section. So anyway, so moving forward, so rho max times BWD, so that is to be, so looking at the calculator, so times BW, so that is to be 300 times depth, and the effective depth here is to be 600. So was that the effective depth? So correct. Okay, so our AS max is now to be equal to 3251.25 millimeter squared. So from that, guys, we can now solve for the value for your MN1. But can we really? Teka nga, so for your MN1, that is basically AS max. So MN1, AS max times D minus A/2. Because if this is to be your D, this is to be your A/2. So it is better, guys, if we would be solving for A first. Or ayun. So let's solve for A. Since we still have one unknown, so for the value for your A, let us just use the value for your C max. So for your C maximum, this is basically 3 over 8 times D. So 3 over 8 times D since we are using tension control here. But if you would be using NSCP provision, this is to be 3 over 7D. Pero nga, yung ginamit ko nga, tension control. So 3 over 8D. So with that guys, so 3 over 8 times D, and what is to be D? 600. So with that guys, so this is now to be equal to, so 3 over 8 times 600. So our answer here is now to be equal to 225 millimeters. Okay, so moving forward, so for the value for your A, so your A max is now to be equal to 225 times betas of 1. So betas of 1 is to be 0.85. So 225 times 0.85. So our answer here is to be 191.25. So 191.25 mm. Okay, so erasing this first. So where can I place this? So for a moment, guys, I'll just be moving this here. So for our value for our MN, this is to be equal to AS, and what is to be our AS max? So that is to be 3251.25. So I would just be writing the formula. So AS max times FY times D minus A over 2. So I would just be storing this 191.25 to my A. So shift store A. And, well, I would be proceeding already. So with that, guys, MN is now equal to, so what is to be the AS max? So 3251. So 3251 point, oops, sorry. So 3251.25 times FY, and our FY is to be 420. So 420 nga ba? Okay, so 420 times D minus A over 2. So our D is equal to 600 minus A over 2. So alpha A divided by 2. So our answer here is to be 688736671. So for a moment. So if we would be if we would be converting this into a kilonewton meter, so we would be multiplying this by times 10 raised to negative 6, because that answer is to be in terms of Newton millimeters, no? Pero sige na nga. So Newton millimeters, so I would just be writing it here. So 688736671.9 Newton millimeter. So if we would be converting this into kilonewton meter, just multiply this by by 10 raised to negative 6. So this is to be the conversion factor. So with that, that is now to be equal to 688.7367 kilonewton meters. So this is to be for your MN1, guys. So do not forget. So that is one way on solving for your MN1. And we can actually solve for MN1 without using our AS max here. So from the start, no? So from the get-go, so from the bininging, the joke lang. So from the start, just solve for C max already. So for example, you did not solve for all of this just yet. So I will just be copying this once again to the next slide. So tandaan natin, ang sagot natin dyan is to be 688.7367. So the first thing that you should do, you can do, is for you to solve for C max and A max, which I already did. So yung formula natin dyan, this is just to be equal to 3 over 8D, and this is to be betas of 1C. And since you already know the value of your A and your C, you can get the moment about this point. So get the moment about this point para hindi mo na isama tong AS max FX. So with that, your lever arm would be this. And the force that you will be considering would be the compression block. Okay. So with that, guys, so for your MN, this is now to be equal to, so 0.85 FC prime. So what is to be FC? 28. And what is to be the value for your A? So that is to be 191.25. And what is to be the value for your B? That is to be 300. Okay. So here, so looking at the calculator once again. Oh, by the way, kulang pa yan. So we still do not have our lever arm. So I would just be moving it here. So equals, times our lever arm, and our lever arm is to be D minus A over 2. So our D is to be equal to 600. So 600 minus A over 2, 191.25 divided by 2. And our answer here for MN1 is to be equal to, so 0.85 times 28 times 191.25 times 300 times 600 minus 191.25 divided by 2. So our answer here would still be the same. So ito pa rin yung answer natin. So once again, you have two approaches. The first approach that I did a while ago was kind of lengthy. Tama ba yung English ko? Basta mas mahaba siya as compared with this method. But take note that they should have the same answer. So 688.736671.9. Okay, so moving forward guys, so since we already know the value of our MN1, so I would just be writing it here. So for MN1, this is to be 688.7367 kilonewton meter. And as you can see that our MN1 is to be less than your MN. So it means that we must also provide MN2 here. So plus MN2. And with this guys, we can now safely assume, we can now safely say that our section here is indeed a doubly reinforced concrete beam. So yun na yung case ngayon. Because let's say that, for example, that our MN1 is, let's say, 800. If this is already 800 kilonewton meters, that means we do not need the help of MN2 already because it is already adequate for MN. But take note guys that you must resolve for this using SRB design. Kasi ang sinolve natin dito is to be the maximum. So bababaan natin siya, bawasan na ngayon natin yung AS niya. Okay, so but since our video here is to be concerned with doubly reinforced concrete, of course we would be designing it by doubly reinforced concrete. Okay, so for the value of your MN2, so I would just once again copy this to our next slide. So dito na lang ako gumawa ng page na bago. Okay. So these are to be your MN1. So this is to be the value for your MN. This is to be the value for your MN1. And this is to be the value, of course, of your MN2. So for your MN2, that is basically, so looking at the calculator, so that is to be 722.22 minus 688.7367. So our MN here is now to be equal to 33.4833 kilonewton meter. So this is to be our MN2 already. So using this MN2, so I would just be erasing the one here on top. And I would once again copy this. So copyhin natin to. So I would just be So I would just be copying this, and let's say, do we have a strain diagram? A stress diagram here. Okay, so this is to be its stress diagram. It may not be drawn into scale, but it kind of looks the same. So ayan, dito na lang lagay natin para sakto. Okay, so it will be up to you on what AS we would be solving first. So we can solve for this one first, so AS1FS, or we can solve for this one first. But in my preference, I want to solve for the tensile bars first. So for the tensile bars, so moving this one aside once again. So let's move it here. So for AS1, so equate this to the moment. So MN2 is equal to, so I will be getting the moment about this point, so that AS prime FS prime would now cancel out. Would not be included in the equation. So with that guys, so AS1 FS, So AS1, so AS1, and FS. So since our section is to be tension controlled, FS is now to be equal to FY. So AS1, FY. So AS1, FY times, of course, our lever arm. So our lever arm here is to be D minus D prime. So D minus D prime. So AS1 Fy times D minus D prime. So substituting known values, that is to be, those are to be 33.4833. And this is equal to AS1. So our AS1 is unknown actually. And for our Fy, that is to be 420 megapascals. And for the value for our D, so D is equal to 600. So this is already given in the problem, as well as for D prime, and that is to be 60 if I'm not mistaken. So yes, correct. So 60. Okay, so moving forward, so we can now solve for the value for your AS. So for your AS, this is now to be equal to, so 33.4833 divided by 420 divided by 600 minus 60. Oh, by the way, guys, so we must, of course, convert this into Newton millimeters first. So take note, guys, that this is to be in terms of kilonewton meter. So if you would be converting it to Newton millimeter, so let us multiply it by a conversion factor. So move ko lang ulit ito dito. And I will be moving this here for us to include the conversion factor, which is times 10 raised to 6. Since we are converting from kilonewton meters to Newton millimeter. Okay, so with that, guys, so 33.4833 times 10 raised to 6 is equal to alpha x times 420. So I think it's just better if I would just be dividing it. So divided by 420 divided by 600 minus 60 times 10 raised to 6 divided by 420 divided by 600 minus 60. Okay, so with that, our AS required is to be 147.6336 millimeter squared. Okay, so this is to be for the value of our AS. Okay, so AS1, I should say. So this is to be AS1. Okay, so we already have the value for our AS1, but what about for our AS2? So I would just be erasing this already. So lagay natin dito, AS1. So for AS2, we will now be taking the moment about this point so that AS1 Fy would be out of the equation. So for AS2, once again, just equate this moment, so Mn2, and this should be equal to, so what is to be the moment here, so that is to be AS prime, Fs prime, times D minus D prime. Because this is to be the value for your D, once again, then yung D prime natin, ito. So subtracting them, subtracting D prime from the value for your D would now result to your lever arm. So this is now to be the lever arm. Okay, so substituting known values. So for Mn2, this is now to be equal to 33.4833. So I will just be multiplying this once again by times 10 raised to 6 for it to be converted to Newton millimeters. Then this is to be equal to AS. So AS is unknown. But what about for Fs prime? So we do not know if Fs prime is known. So for your Fs prime, we can solve for it. So note, for your Fs prime, we can solve for it using, so 600 times C minus D prime divided by C. So this equation was already derived in the previous video. So with that, guys, so Fs prime is to be equal to, so substituting known values, so 600 times, so I would just be writing them here, so 600 times what is to be the value of RC. So same lang siya sa kanina, so which is to be RC max, so C, so 225. So ito yung na-solve natin kanina. So with that, that is now to be equal to 225 minus d prime, and our d prime is to be 60, divided by 225. So with that, guys, so fs prime, so this is now to be equal to, so 600 times 225 minus 60 divided by 225. So our fs prime is now to be equal to 440. So 440 megapascal. And our Fy is to be equal to 420. So muntik na. So with that, guys, since Fs is to be greater than your Fy, use Fs equal to Fy. So with that, guys, this is now to be equal to, so this is 420 already. Okay, so tatanungin ko sana kayo kung nagets nyo pero walang sasagot kasi nga video nga to eh. Basta ganyan yan. So if there are questions, feel free to message me. So anyway, so I will just be removing this. So there, and for the value for your D and D prime. So D is to be 600 and your D prime is to be equal to 60. So this is already given in the problem. So for the value for your AS, this is now to be equal to, so 33.4833 times 10 raised to 6 divided by 420 divided by 600 minus 60. By the way, mali to, so divided by. Okay, and since both of them yielded, so AS1 and AS, so they would be 147.6336 millimeter squared. So guys, as you can see, they have the same answer. So for your AS prime and your AS1, they are actually the same, but it is not always that case. So take note of that. Okay, so the next thing that we will do is for us to detail already. So for our detailing, guys, so nasan ba yung, ito na lang. For a moment, just be copying this where. So I think I'll copy it here. So AS prime, so for your AS prime, this is to be 147.6336 millimeter squared. And as for the value for your AS, you should add AS max and AS1 because AS is, well, basically AS max plus AS1. So once again, AS max plus AS1. So for your AS max, ano nga ba yung AS max natin? That is to be equal to, so AS max, where are you? So 3251.25. So 3215.25 mm squared plus AS1, and this is also equal to 6336 millimeter squared. So with that, guys, the value for my AS is to be equal to, so 3251.25 plus 147.6336. So our answer here is to be 3,398.8436 millimeter squared. So we have this and this. So the next thing that we will be doing here is for us to get, so copy ko lang ulit, so is for us to get the total number of rebars required. So once again, it will be up to you on what bar diameter you will be using. So I think I will be using, let's say, 28. So let's try. So try diameter 28 mm. So for AS prime, so for the number of compression bars, so NC bars, that is to be equal to, so 147.6336 divided by pi over 4 times 28 squared. So basically, guys, you only need a fraction of 1 rebar as per AS required. However, guys, you are required, the minimum required still pieces that we can put is to be 2. So kasi kapag 0.28 yan, and if you won't be rounding it up to 1, it is just only here. But it is not allowed in special moment resisting frame. So for 2 pieces and below, you must provide 2 pieces. So 2 pieces yan. So with that, guys, I will be providing 2 pieces. So where was that? So 2 pieces. Rebars. Okay, and as for our tension bars, so N tension, so this is basically, so AS divided by pi over 4 times 28 squared. So with that, guys, so 3398.8436 divided by that. So our answer here is to be 5.5198. And we will be rounding this up to 6 pieces. Since you cannot buy 0.5198 of a fraction of a steel section. Okay, so the next thing that we will be doing here is that we will be computing for the spacing. So yung spacing naman ngayon. So for the spacing, of course, that your SC should be greater than or equal to 25, should be greater than or equal to 28, should be greater than or equal to 4/3 MSA. So let's assume that for our MSA, let's assume that this is to be 18 mm. So assumption na lang since walang given. So since it is not given, we will be assuming that this is to be 18 mm. Assumption. Okay, so for the value of your spacing, so kunin lang natin yung spacing niya dito. So ayan, nalimutan ko na kung anong ginagawa dyan, no? Pero meron ba tayong given dito? So we do not have a concrete cover and we do not have shear reinforcement. So puro assumption na lang. So assume, let's say dV equal to 10 mm. So this is to be for your shear reinforcement. And we will also assume that concrete cover is to be equal to 40 mm. Okay, so with that, for our spacing of clear cover, so you should already be familiar with this. So 2 times dV minus 2 times cc minus n times dB divided by n minus 1. If you do not memorize that, just draw your figure. If you have 6 pieces, so 1, 2, 3, 4, 5, 6. So just compute for the clear spacing between them by any means necessary. Kung kaya nyo mag-integration, kayo bahala. So ayun guys, so if I am to be doing it this way, so substituting known values, so 2 times 10 mm minus 2 times 40. Oops, I'm sorry guys, may kulang pa tayo dito. So BW. So we would be subtracting all of this. So BW minus all of that. So from that guys, so nakalimutan ko na. So 300 nga pala ito. Minus 2 times 10. Minus 2 times 40. Minus n. And our n is to be 6 times 28. Divided by 6 minus 1. So I think this would be inadequate, no? So BW. So 300 minus 2 times 10 minus 2 times 40 minus 6 times 28 divided by 6 minus 1. So our spacing here would be 6.4. So it means that, so since our spacing, our SC here, is to be 6.4 and it is not greater than any of this. So it means that in our spacing, this is already inadequate. So the next thing that you will be doing, which I will not show in this video any longer, is for you to adjust the parameters. So for example, guys, that your BW is to be 300. So if you are already designing a certain section in your laboratory works or in your actual professional practice, you might as well increase the beam width so that the spacing would, let's say, the spacing would be adequate already. Or better yet, if let's say you want to stick with your section property, so nasa na naman yun? So for example, that you want to stick with your section property here, which is to be 300 by 600. You can lay this out. So you can lay out the 6 pieces here. Let's say in 2 layers. So maybe you want it to be 4 pieces here and you want it to have 2 pieces at the second layer. But take note guys that you should check for adequacy or you must resolve for it. So it is better guys if you would be drawing it this way. So solve nyo yung bagong D. So solve for the new D here. And once that you have solved for the new D, analyze for this section and solve for its nominal moment. So solve nyo na lang and check if it is to be greater than or equal to your MN. So yun lang naman yun, guys. So these 6 pieces here are theoretically adequate, but it is not adequate as per the code. So in terms of nominal moment and in terms of theory, it is already adequate, pero bawal daw siya, sabi ni code. Kasi mas maliit siya dito sa mga ito. So 6.4. So assuming that my calculations are correct, and which they are. Okay, so another way for you to do, to, let's say, to change the spacing is for, of course, to change the diameter of rebars. However, as I can see, 6.4 to masyado nang malayo. Kahit ano atang rebar ilagay niya dyan. Unless maybe, let's say 36. So let's try. So AS natin is to be 3398.8436 divided by pi over 4 times, let's say, we would be using 36 diameter rebar. So we would be having 4 pieces. So I will just be checking here if kasha yung 4 pieces. So 300 minus 2 times 10 minus 2 times 40 minus 4 times 36 divided by 3. So hindi pa rin siya adequate kahit 36 mm yung gamitin. Or let's say if you would be using 50 mm steel, maybe that is already adequate, but it is not advisable any longer because those steels are only subject to pre-ordering. So you can only use them if you would be pre-ordering them. So ayun. So that is basically the idea in designing a structural reinforcing concrete. I mean, that is to be doubly reinforced. And yeah, so that is basically our video for today. Okay, so if there are any questions, feel free to message me.